All right, so geometry 6.1, the polygon angle sum theorems. So now we already talked about the triangle angle sum theorem. Well, now we're going to talk about some bigger ideas involving all polygons. Okay, so this idea of polygons. So in the next slide, I have a little brief review of polygons. So again, these are all called plane figures. They're all 2D figures, and a polygon is a closed figure formed by 3 or more segments. So again, a polygon has to be closed, and it has to be created by segments. All right, so we're not including anything with curves, no circular objects here as well. So again, you have these endpoints, right? These are called vertexes or vertices where these sides meet, and then your segments are the sides. All right, so you have vertices or vertex and sides. So here's some common names of polygons. So again, 3 sides is a triangle, 4 sides is a quadrilateral. That's what chapter 6 is about. So if you want to make a note of that. So chapter 6 is about quadrilaterals. Then we have pentagons, hexagons, heptagon, octagon, nonagon, decagon, hendecagon. That's new for me. And then dodecagon. And then again, just generic, you'll see an n-gon, which has n sides. Okay, I'm not quite sure if we're going to make you remember these, but again, if you don't know something, if the problem says hexagon, just Google it. How many sides does a hexagon have? Okay, all right, simple. Okay. So, sorry about that. Okay, so the 2 main ideas about these are the polygon angle sum theorem, which has to do with the interior angles. So, sorry about that, interior angles. So, for the polygon angle sum theorem and your interior angles, it always says the sum of the measure of the interior angles of an n-gon is n minus 2 times 180. So, the sum of your interior angles is always n minus 2 times 180. Now I'm going to go explore that in Desmos geometry real fast and explain why that is the case. All right, and keep in mind that number 180. All right, so if we go to Desmos geometry, and let me quickly just draw, I like to use pentagons, right? Okay, so let's use the pentagon. So pentagon has 5 sides. So 1, 2, 3, 4, 5. So nothing special about this pentagon, right? So here's what I want to do, okay, is I want to take a look at drawing what are called diagonals. So diagonals start at one vertex and do not touch a consecutive vertice. So this would not be a diagonal because it's a side of the polygon, but this would be, and this would be. And now I want to create polygons, and I want you to tell me what this pentagon, this 5-sided figure, is broken into. So there's one, and let's color that red. And then we'll do this one. Here's 2, and let's color that blue's fine. And then the last one. And we'll color that one, I like green. Cool. So now you can see that this pentagon that I started with, this 5-sided figure, was broken into 1, 2, 3 triangles. Well, what is the sum of the angles of a triangle? Well, the sum of the angles of a triangle is 180. Well, this pentagon is now made up of 3 triangles. 3 times 180 is going to be the sum of the angles inside this pentagon. Well, where's that 3 come from? Well, think about this. This is a pentagon, right? It has 5 sides. What's 5 minus 2? Oh, it's 3. And there you go. That's where this formula comes from. It's the number of triangles your figure can be broken into, n minus 2 times 180. So again, this right here, this n minus 2, is the number of triangles in your figure. And again, you have to use one vertex and draw all the diagonals. And then times 180 because there's 180 degrees in each triangle. Now, the polygon exterior angle sum theorem is a little bit different. It says the sum of the measures of the exterior angles of a polygon, one at each vertex, is 360. Is 360. Notice there is no n mentioned. This is not dependent on the number of sides. Not dependent on the number of sides n. That's an important idea. So for any polygon, it could be a triangle, a quadrilateral, a pentagon, hexagon, heptagon. It doesn't matter if there's, the number of angles that are in the exterior. They should all add up to 360. Okay, there we go. Now there's a cute little, not proof, but just like quick algebra that we do. But I'm gonna spare you that. Okay. So again, just keep that in mind that the exterior angles add up to 360. If you want to see that little quick algebra problem, ask me and I'll show you on our Google Meets. Okay. So now, let's talk about some different classifications of polygons. So equilateral means that all of your sides are congruent. So notice here in this equilateral hexagon, all the sides are congruent. Equiangular means all the angles are congruent. So notice all the angles of this hexagon are congruent. But the gold standard, which is called regular, a regular polygon, is both equilateral and equiangular. And most of the time in our world, things are equilateral and equiangular. If you look at a yield sign, for instance, that is a triangle. It's a regular triangle or an equilateral triangle. If you look at a stop sign, it's going to be a regular octagon. Okay, so there is a way to find the measure of each interior and the measure of each exterior angle of a regular n-gon. So to find the measure of each interior angle of a regular n-gon, you're going to take that sum and divide it by n. So again, just think of it as the sum of the interior angles divided by n. Okay. Same kind of idea for the exterior angle. So say I want to find each exterior angle of a regular n-gon. Well, the sum is 360. You're going to divide by n, and that's going to give you the measure of each exterior angle. And I do want to draw your attention to this idea, right? And I'm just going to do it down here. I don't know if I'll do purple. So say that this is part of my polygon, right? This is my interior angle. And then right here, this is the extension of one of the sides to create my exterior angle. Do not lose that story that your interior angles and exterior angles are linear pairs. Keep that in mind. So your interior and exterior angles are linear pairs. So they themselves add up to 180. Remember, they're supplementary. So keep that in mind. It's an important idea. Okay, I like to make connections amongst my things. All right, so that's the notes video. A couple problems coming up in the following videos.